company. My name is Marisa Fernandez, and I'm an analyst here at Sidoti. The format of the webcast will be a 20-minute presentation followed by Q&A. If you'd like to ask a question, please click on the Q&A button on the right-hand side of your screen to type it and submit it, and I'll ask it for you. With that, I'm really pleased to welcome David Corso, Chief Financial Officer of American Battery Technology. Please go ahead, David.
Thank you very much. Pleased to be here and pleased at the level of interest. It's been fun today. So I drive our marketing people nuts because they make these great decks for me, and then I flip around through them, so I don't take them in order. So in the Q&A part, anything that I may have left out or wasn't answered, please help me with that, and I'll address it. But I think what I'd like to do is, if I can move the screen here, is just kind of get to the things that I think are most important for somebody to know about American Battery Technology Company. So most of you, if not all of you, are pretty familiar with this marketplace and how fast it's moving and the interest in it. So important things to know about American Battery Technology is we are in the midst of certainly a growth market. And in terms of pricing of feedstock and pricing of refined metals, it's almost like we're participating in the creation of a new financial market. So our important thing about us is our technology has been affirmed by some major entities like BASF and DuPont, which are the two largest chemical companies in the world. In a couple of weeks, there will be an announcement that will come out through a consortium of the Department of Energy, where our technology has been affirmed and has been chosen as a partner for Ford, GM, and Chrysler in terms of processing at least some of their feedstock, and then also them being a customer for us in terms of our refined critical metals. And we define critical metals within the EV battery space as cobalt, nickel, lithium, and manganese. We also, part and parcel to the quality of our technology and the differentiation, is we've recently received a grant from the Department of Energy in conjunction with DuPont, where we're going to be building a demonstration model in Western Nevada that will process about 5 metric tons of clay stone per day, and we'll be extracting the lithium from that clay stone. So as I mentioned earlier, we have partnerships now with certainly the Department of Energy, DuPont, BASF, U.S. automakers, and the Critical Materials Institute, and others. We are building, shortly we'll begin construction anyway, 20,000 metric ton per annum production facility, lithium-ion battery recycling plant in Fernley, Nevada. Nevada's been a great place, very friendly, and we are nearing the end of the permitting process. So we hope to begin construction in a couple of months. Our engineers, most of them had a tenure at Tesla as in R&D and battery creation. So as I'll get into in a few minutes, we're disruptive, and we have a real differentiation in how we go about recycling lithium-ion batteries. I think that the term of our art now is moving from recycling to resource recovery, which I kind of like more. So we'll get into that as well. So as most of you know, there's a lack of primary supply that's going on in terms of the push towards electrification. Battery and recycling, especially in how we do it, is green, it's sustainable. Metals, critical metals like lithium, manganese, nickel, cobalt are almost infinitely recyclable. So they can be used over and over and over again, as opposed to the fossil fuels that get burned up. The classic business issue here is to state the pain or the problem, and here it is. Only 1% of global battery materials are produced in the United States. Most of what is recycled goes to Asia for recycling. What isn't recycled, at least from the United States, seems to end up in landfills. So there's a fortune of economic value going into landfills. So China, Korea, Japan are doing primarily most of the recycling that's done offshore. And again, the U.S., we don't produce any lithium. We don't mine it. So it's almost, for those of us that are U.S. citizens, it's almost a national security issue, maybe akin to what went on with the petroleum reserve. So this administration has indicated they're serious about building up a critical metals supply and encouraging recycling. So we're planning on participating and taking advantage of that. Again, stating the problem. So majority of batteries are recycled outside the U.S. They're mostly melted down at 3,000 degrees Fahrenheit. So you have pollutants, and you don't have the kind of recoveries of the critical metals and other materials that are in those battery modules. So our technology is very different than that. Again, disruptive, and it's got a great differentiation. We try and keep track of, as best we can, the market and companies that we follow or consider to be competitors, or maybe even someday sort of partners. Maybe they'll be customers, maybe we'll be their customers. So again, the difference that's critical and is a real differentiator for us is how you recycle, and especially how do you recycle on the front end of the process. If you're pulverizing or melting batteries, then best case is a 40 to 50% recovery of what's most important in terms of the metals in those batteries. We don't do it that way. We reverse engineer the process, and then so that's a mechanical process on the front end. The back end is a hydrometallurgical process where it's mainly chemical for us. So we don't lose components, we don't melt them, and there's minimal amount of airborne or fluids that could be considered pollutants. We have a closed loop where we capture all of that and treat it. Again, the closed loop that everybody talks about is primarily right now an open loop, and we are proposing with our technology to make that closed loop. So you start with the feedstock, you go through the processing, and then it's what do you lose in the process that creates pressure for more mining. So in our closed loop, at some point maybe we'll take some of the pressure off of mining, and at some point maybe it equivocates a balance between what's recycled and what's needed to be mined. But this is how we see what we do to close that loop. And again, our focus is on lithium, nickel, cobalt, manganese, copper, aluminum. For us, initially, copper, aluminum, and steel will be scrap metals that we will sell. Our mechanical process gives us a black mass that we might sell, but it's also the what we need to create our refined metals for cathode manufacturers and the like. What we talk about internally is how we reverse architect or demanufacture the process. So many of our engineers worked at Tesla. Some of them actually built the factory, and Ryan Meltzert was an engineer there who was an R&D engineer for Tesla, and also created their battery process and what they thought might be battery recycling. I believe the company decided to not do that and just focus on producing automobiles, which they do really well. So our engineers who worked there saw how the battery construction process, the manufacturing process worked. And at a sort of a summary level, we are reverse engineering that, but there's more to it than that, and that's proprietary. We are certainly moving down the path of filing patents. So notable affirmations of technology. So in late 2019, BASF, the largest chemical company in the world, but essentially ran a contest for the best battery recycling technology, over 100 applicants. So it was a highly competitive process. We were named the sole winner. And so we now work with BASF on a regular basis. They host us in their Greentown labs, where we have, what chemical technology to use, and enjoy a great strategic relationship with them. Again, back to the closed loop and how primary resource extraction is also a technology that we possessed. So not only possess, so we not only can recycle, but our technology facilitates extraction from mining claims. I'll talk more about that in a minute. And the minute went by quickly. So we got a $4.5 million grant we were awarded from the DOE in conjunction with DuPont to create this demonstration program in Nevada to extract lithium from claystone. This will be a 3-year project for us. This is a parallel endeavor that doesn't affect our focus or our timing on recycling, which we see is our primary machine right now. Our primary engine is recycling. There is the potentiality perhaps to license our extraction technology to those who are doing heavy duty mining and lithium and other mining, South America and elsewhere. So it's another possible revenue generator for us, but right now this is just a demonstration project. This is our team. You can see Ryan. We just recently added Andres Mesa as our Chief Operating Officer. Scott Jolkover was at Comstock for many, many years, and the rest of us have variety of logistics, manufacturing, and financial backgrounds. Board of directors, all very, very experienced, accomplished entrepreneurs. We got a great board. So to sort of finalize this, so what to remember about us is we're in a huge growing market. Our technology is award-winning and has been affirmed by major corporations. We can both participate in recycling and metal extraction. And we have, as I mentioned, we have partnerships with BASF, DuPont, US automakers, have a good relationship with the Department of Energy. Certainly So the pilot facility is a $35 million budget, 20 million for construction, 15 million for capital equipment. We have started to purchase capital equipment, and we are in another fundraising round to fund the budget on the pilot facility, and obviously a highly experienced team. So I think I ran through that in less than 20 minutes.
But we do have a lot of questions coming through, David, so we'll use those extra minutes here. So a couple of people asking the same question. What would you consider to be your greatest competitor?
Well, certainly we have competitors. We want competitors. I would never say we don't have any. I went through some of the attributes of the companies we listed here. I think Redwood could be, Li-Cycle could be, but again, we have somewhat different point of view on what our core business is. And we also have the ability to do primary extractions. So we consider ourselves to be disruptive and to have good differentiation. Maybe, certainly a recovery rate is a differentiator in how we process things. So I think it's evolving. As I mentioned earlier, I think we probably will do business with some of these folks. And we keep track of them. We watch their progress. We learn from it, and maybe they learn something from us. So a long-winded answer that didn't exactly answer the question, because I'm not sure. I mean, it's still evolving. So we'll see, but certainly we do. And I think it'll get sorted out by supply chain issues, like where do we get our feedstock and who are our customers? And so I think it'll become separated by that. I think some of us will end up with the same sources of feedstock, and some of us will end up with the same customers. Just, like a General Motors wants to be careful about who its primary sources of metals is from. So anyway, I'm not sure, I guess is probably what I should have said, but they're out there, and we're friendly, and we keep track of what they're up to.
Okay, thank you. The pilot program that you're doing, what is it exactly trying to prove? What metrics are you using to be able to say it has achieved its goals?
Okay, the first part of that was, I'm sorry, I didn't catch it.
The pilot program is trying to prove what exactly? What are you trying to prove?
Okay, great question. Sorry, I should have covered that in a little more depth. So the pilot factory in and of itself is a sustaining positive cash flow enterprise at full production. So first revenues will be late Q2 2022. Full production will occur in first quarter of 23. It's a $160 million gross revenue business, 25% cost of goods sold, and 65% EBITDA against that $160 million gross revenue number. So what are we trying to prove? We are proving, again, that the technology works. We are proving that at 80% throughput, it throws off a handsome amount of free cash. And it is the basis for which we will build much larger, fully commercialized lithium-ion battery recycling facilities. So the second and third and fourth and fifth facilities will be at least 100,000 metric tons of annual processing capacity versus the 20,000 metric tons that the pilot factory will be. But the reason why it's smaller and we're calling it pilot is it is a demonstration of the capacity of our technology and how quickly we can move feedstock through the factory. So for example, if we take 1 ton of feedstock, we can move that through our factory in a matter of hours, which is a great contributor to the margins I just mentioned. Thank you.
Also, right now, what you have is at the lab level in Boston, is that correct?
We have a lab level in Boston and also at the University of Nevada, Reno. We have a lab here too. And so we do more than bench scale, but that's where we started. So at the lab here in University of Nevada, Reno, we actually are also refining metals.
Got it. What is the estimated cost per ton of the recycled metals, and how does that compare to mined metals?
Great question. So let's start. I think where the question is cost of goods sold, right? I think that's where this is about. So there's a bifurcation between what is the cost of feedstock and what is the processing cost in a ton. I think is that the question?
So I think the question is it going to be cheaper or more expensive for someone to source battery metals from you as opposed to a miner?
I see. Okay. Well, so in the raw form versus our refined form, I think it's much more cost effective to source it from us, but it depends on the use. So for a cathode manufacturer, having a highly refined metal from us shortens the entire process. And again, remember that these critical metals, as we define them, are infinitely recyclable, so we can process them again and again and again in a fairly short time period. We're not miners, so that's a very expensive process. I think that it's cheaper to get it from us.
Is it fair to say that the price of your metals could be, depending on your manufacturing cost, kind of stable compared to the cyclicality of metal prices from mines?
Well, they're two different things, right? So you have a metal in an unrefined form, and then you have metal in a refined form from us. So what we look at is we look at the London Metal Exchange in terms of spot prices, cash prices, highly refined metals versus raw. And so if you're building EV batteries, I think we're going to be a very reliable, consistent source. The pricing, way we do our pricing right now is we use LME. We do a 3-year backwards look and a 3-year forward look as best we can. And we look at what is the value of highly refined metals, again, nickel, cobalt, lithium, manganese. And that's how we project pricing going forward in terms of the prices at which we'll sell our refined metals. Maybe I'm not understanding the question, but it's something that comes out of a mine versus something that's highly refined are two different things.
Yeah, well, the mine metal would have to go through the refining process afterwards, right? But that's great, thank you. So does American Battery Metals worry about OEMs creating lithium recycling technology in-house like Tesla did?
Well, yeah, so sure. Competition can come in a lot of forms. I think it was only a few months ago that Tesla announced that it had no interest in battery recycling. And I know the other day they announced that now they had capacity, or they wanted to build capacity to do that. So I'm not sure what's going on there, but yeah, they certainly have in their factory, there's a certain amount of battery waste that's produced, and it would be, I think they wouldn't have much problem taking what the battery waste they have and running it through a recycling process. I don't think currently they have that capacity. In our discussions with GM, Ford, and Chrysler, I think they may eventually be in that business. I think we can still be a partner. We can be a vendor. They could be a customer for us. So it will evolve. And I think our view of that and our angle of attack is to form critical relationships that can be sustained and where we add value to the manufacturer.
That's great, thank you. Another question, where is ABML in your talks with Fernley on their last permit before construction?
We are in the final phases of that. We are providing equipment data. We are providing, flow process where the P&IDs is coming around into its final form. So it's mainly those items there, and then satisfying any other concerns they have. I think everybody knows that we got a universal approval several weeks ago from the city of Fernley for what we're doing and what we intend to do. We are just finishing being in compliance with all of their permitting issues. So we hope to, in a couple of months, to be in construction.
I think we have time for one more here. How much money is being raised and what are the terms? Who are you talking to get the money, end users or mining investors?
And the last was what about mining investors?
Who are you talking to get the money from, end users or mining investors? Meaning customers or investors?
Sure. Not customers, and at this point, not mining investors. What we're doing is we're talking to investment funds, potential institutional funds. Again, we have the ability through our equity line of credit or our S3 effective approval to raise money from the sale of our common shares. And in fact, we are doing that now on a very prudent basis with our equity line of credit. And we are moving some shares periodically out into the marketplace. But the budget for the pilot factory is $35 million. We have some additional capital needs for sort of ongoing operational expenses, and then some of the other accretive opportunities that we are also taking a look at. We have mostly completed the funding for our permitting. We are starting to buy capital equipment. So, we've got to satisfy the $35 million need for the factory. Currently, we have about $8.5 million in cash, and we have no debt. So certainly over the next several months, we'll be raising somewhere between probably $35 and $40 million.
Great. Well, I think that's all the time we have today. I want to thank David and American Battery Technology and all of our investors that joined us. Thank you, everybody. And that concludes today's presentation.
Thank you, everyone. Appreciate it.